Hi everyone. Let's take a look at the following example. Graph y equal to x squared plus 1 divided by x. Step 1. Write down all the vertical, horizontal, and potentially oblique asymptotes. So if you really look at this question carefully, by inspection, you have to look at the restriction, which means in this case, the denominator x cannot be 0. And since x cannot be 0, there'll be a vertical asymptote located at x equal to 0. Step 2, if you look at the degree of the numerator relative to the denominator, they're not the same. In fact, this is going to be 2, that's going to be 1. Anytime the degree in the numerator is 1 greater than the degree in the denominator, there's going to be an oblique asymptote. And to do this, you have to go back to dividing. So again, you can use the shortcut. Remember, x squared plus 1 is like the same as x squared plus 0x plus 1, which is 1, 0, and 1. If you're dividing it by x or x minus 0, you can put a 0 here. Again, you copy, you multiply, you add, you multiply, you add. That's going to be the remainder. And the quotient is going to be y equal to x. So this is how you know that the oblique asymptote is going to be y equal to x, which means there'll be no horizontal asymptote. Now, just in case you're thinking, is there another approach? I mean, I don't want to divide all the time. Can I just simplify this? Of course you can. If you break it apart, right, this is x squared divided by x plus 1 divided by x, which is the same as saying x plus 1 divided by x. That's a nice framework to immediately identify the oblique asymptotes. Again, that's the second approach to doing this. Now, again, I would say when you're graphing this, don't do it at the end. I would always encourage you to graph as you go. So again, if I'm just looking at a couple of points here, let's say up and down by 1, left and right by 1, I know in this case, there'll be a vertical asymptote at x equal to 0. There's also this oblique asymptote at y equal to x. So now you can move forward to the xy intercepts. And again, it is okay sometimes that there are no intercepts. So let's find out. To find the x-intercept, you're going to set y to be 0. You're going to solve for x. And you can just focus on the numerator and notice how this doesn't really give you any real values. I mean, technically, there are a pair of complex roots, but that's not the answer we're looking for. There are no real roots. Likewise, if you want to find the y-intercepts, that's going to be 0 plus 1 divided by 0. Again, that's going to be undefined. So you're not going to be able to find xy intercepts, and that is okay. The next step is really to grab a bunch of points. So I would say pick, for example, x equal to 1, see what happens. Is the y value going to be above or below the y-intercept? Or not y-intercept, the oblique asymptote. So if you plug in x to be 1, that's going to be 1 squared plus 1 divided by 1. This is going to be 2. Now, if you plug 1 into the oblique asymptote, that's going to be y equal to 1. So very quickly, you discover there's a point here at 1, 2. And this kind of signals to you that the graph is going to look something like that. Now, of course, you can still find the behavior near the vertical asymptote and behavior to kind of justify this, but that's a nice, fast method to figure out where the graph is going to be located. Same thing with -1, right? If you plug it back in, that's -1 squared plus 1 divided by -1. And that's going to be 2 divided by -1, which is -2. Again, you go left by 1, down by 2. And this kind of helps you to see that the graph is going to look something like that. Again, you can label the function just like that. Now, last but not least, and this is probably the most important step, everybody, sometimes a graph may cross the horizontal or oblique asymptote. A graph can't really cross the vertical asymptote because x cannot equal to y, but you always want to double check. So in this little box here, I'm going to say, well, does the function cross? Well, y equals to y, and x is the oblique asymptote. This is the original function. Let me zoom in for you. And now if I can solve for x, that means it does cross. If I cannot solve for x, it doesn't cross. I cross multiply, x squared equals to x squared plus 1, 0 equals to 1. And this doesn't make sense. So this tells you that the function does not cross. And this is basically how you graph y equal to x squared plus 1 divided by x. If you find this math video meaningful, it's adding value to your life, comment, like, share, and subscribe. I hope this makes sense.